So a warm welcome to the keynote for the 2017 Interpreting Your Genetics Summit, brought to you by the Evolution of Medicine. A warm welcome to everyone who's listening from all across the world, and it's an absolute pleasure to welcome for the keynote address for this event, Dr. Jeffrey Bland. There could really be no other person in my mind to deliver this. For those of you who are unfamiliar with Dr. Bland, he is the writer of a book called The Disease Delusion, which is an incredible book. He's the chairman emeritus of the Institute for Functional Medicine and the founder of the Personalized Lifestyle Medicine Institute, among many other things. And Dr. Bland, it's such a pleasure to have you here to kick off this summit.
Well, James, I can't tell you what a privilege it is to be part of this summit. I think it's very timely, and as always, as you've kind of prospected the field, you're always right at that leading edge. And I believe that this is an opportunity to really help people understand where we stand today in this whole omics revolution and how it can empower individual health in ways that we never dreamed possible as little as 15 years ago.
Absolutely. Well, look, it's 2017, so that's a great place to start. And I think an amazing place to start this whole summit would be for you just to sort of share with us a kind of a state of the evolution of the field of genomics and sort of where we stand today. And then we can go into, maybe a little bit of the past, a little future. But in 2017, what is the state of play with the genetic and genomic revolution?
Yeah, thanks very much. I'd like to answer that in a little bit of maybe a non-traditional way, and I hope you and your listeners will be able to follow along with me, because I think this evolution of the genomics area has some similarity in context to what happened in a previous remarkable technology revolution that occurred in this country and actually had global impact in the late 70s and into the 80s. And that, of course, was the age of the microcomputer and in the development of personal computing. And I recall so clearly back in the early 1970s when there was the All-Tech computer and there were these hobby stores where you could go and you could build your own little rudimentary computer. And then we got into the first days of simple computing with compact and it was seen as kind of a hobbyist thing that only a few techno nerds were interested in and would really never have direct applicability to the population at large, because quite honestly, we had computers and we had computer specialists and we had IBM computing centers and we had IBM 360 computers and then later Cray supercomputers and that was all kind of just great for people that wanted to do computing. So why would individuals other than hobbyists be interested in this area? And of course, making consumer friendly, first with the ability to bring software that were able to empower people to do simple things like word processing, and then the spreadsheet and scheduling with the early software programs that bundle those things together. Some people said, well, that's going to make my work a little easier, so I'll give it a whirl. And we had a battle between whether it was going to be CP/M or DOS as the language, and eventually, as you know, Microsoft won the battle. And so we had this interesting transformation of DOS-based Microsoft computing, and then, of course, this fugitive revolutionary group down in Cupertino, California, Apple Computer, that had this kind of a little bit different view of how to consumerize computing, to take it away from computing and take it into being a personal instrument for information development, information science, to empower people to own information that was previously owned by other people, and they had to go with on bended knees to ask their permission. They could get access to the information. Now suddenly maybe we could have people have their own information and they could get what they wanted to know and they could do things that were on their agenda. And so computer science then became personal computing, became personal assistance, became extracorporeal brain over the course of really just a decade. And what might have seemed so bizarre in the late 1970s that everybody would be doing computing, which is really what happens in our smart devices today. We have super powered computers in our smart devices, just seemed totally unrealistic. Now, how does that relate to what's going on in genomics today? I think it has a direct parallel, because we started off, first of all, in evolving the technology, similar to like chip technology and Silicon Valley and with the computer world. And then that moved into hobbyists, I would call them the early adopters of genomic testing, who were kind of the N of one quantified human devotees. That's really a small percentage of the overall population that would have that level of kind of geekism about them. And then we moved from that era in genomic testing to where we started to see commercialization of genomic testing, probably a little bit premature with a number of companies that were, providing things like nutrition and dietary advice from early SNP analysis. And many of those companies, as you know, didn't survive because they really didn't have that much to say, quite honestly, because the science was too early in the interpretation of this information. So we kind of had a little bit of a quiescent period. Maybe even it was a disillusionment, because in the early 2000s, the post-Rose Garden description of the Book of Life, the Human Genome, there was this great enthusiasm that we would solve all problems, and pharmaceutical companies were developing all these drugs around specific genes. And then we found that the story is much more complex than we initially thought it to be. So for a period of maybe 10 years, we went through this rising interest and then kind of a falling off with disillusionment. Now, just similar, I think, to the computer revolution of making personal computing user-friendly, with the increase in understanding of the information within the genome, with the starting to recognize these epigenetic effects that modulate how genes are expressed and the effects that lifestyle and environment have on the epigenome and on genetic expression, and starting to be able to do big data analysis of families of genes rather than one gene at a time, we're starting to have a new reawakening of the power of genomics for evaluating not how we will die, but how we will live. And that is a very remarkable transformation that we're right in the middle of it today in 2017, in which over the next years to come, and when I say next years to come, I don't mean decades, I mean years, we're going to see this advance as rapidly in application and simplicity of understanding to the average consumer as we saw with the complexity of microcomputing. And, it used to be before graphical user interface that you had to know certain code words in order to use your microcomputer. And then once graphical user interface got there where we could use point and click with a mouse and with pictures, then suddenly it became accessible to virtually everybody. And that is exactly what's happening in the technology, I believe, in the omics world right now, where we're going to see big data merging with social media, with wearable devices, and with omics to create a new view of the person that makes themselves much more understandable to their strengths and weaknesses, and how they would design a program for their life that would maximize their opportunity to have their full potential of their genes expressed in health, rather than worrying about are they at risk to disease. Now, if I was to take that long kind of soliloquy that I just gave, or a little monologue, and try to map it against what's going on in the world of today, just to give some reality base to it, let me give a couple of facts as I see it. We have a variety of very wealthy young people that have risen up through their genius or their talent being expressed into the computer software world. And we can think of the founders of Google, obviously. We can think of the founders, or the founder of Facebook and, Flickr. And you can just go down the list of these software companies that have emerged, that have been born out of the creation of a single individual, often, generally a person that's quite young, and they become very financially comfortable, sometimes more than comfortable. They become very wealthy. And a good example of that is Mark Zuckerberg and his wife, Dr. Chang, who now in their financial level of success, like so many of their colleagues, are saying, well, what do we do to really create value in the world? Where are we going to take our knowledge and our wealth and really do something? And so, as you know, the Chan Zuckerberg Initiative was formed recently with the principle to advance human potential and equal opportunity through various projects that they're going to fund. I think it's $1 billion that they've committed to initially, to do innovative things, fund and support innovative things that are going on in healthcare. of which this whole concept of personalization will be one of their foci. The same thing is going on simultaneously, as you know, with Verily Life Sciences with Google, in which the Google founders, who also have the financial capability and vision to look out to where the puck is going, have said, we ought to put some of our knowledge and our financial strength into really looking at health, because health is one of the major principal values that all people share. And so this Verily lives at the intersection of technology, data science, and healthcare. And its mission is to make the world's health data useful so that people can enjoy healthier lives. Now, you'll notice that we're talking about people who are deploying some of their resources, both financially and intellectually, from the computer world now into the healthcare world and into omics, because all of these relate to aspects that have to do with genetics. So Verily now has got this project Baseline, which is looking at various genomic risk factors and genomic factors. This is a partnering with Duke University and Stanford Medical School on this project Baseline, and they want to have 10,000 participants over the next 4 years that they will get complete genomic and health information to start encoding large databases so we can have enough information to make intelligent decisions about individual healthcare. Then if we take that on to say, well, how does this relate to changing the whole way we've thought about health in the past? Well, in the past, we've thought about health as an aggregate to disease. And that is, we don't want to have some name associated with our health, like diabetes or cancer or heart disease or arthritis or whatever it might be. So we've been very disease focused. And once you have a disease, what you've been put into is a class, because it's assumed that all people with the name of the disease, say type 2 diabetes, must share in common the same things. And therefore, they should all be treated very similarly because they have the same condition. And what we've recognized now through genomic science is that actually is not true. If you look at any specific one of these chronic diseases that are commonplace in our culture now, what you will find is that people with the same name disease have very different patterns of genetic expression that result in those diseases. So they are really unique experiments of which they're an N of one. And it just happens that they get aggregated together based upon their signs and symptoms into a general name called that disease. And then they're treated as if they're part of the average, which really is biologically not true. And so it explains why we've had so many treatment failures and so many people with adverse effects from various treatments on drugs, because they were treated as if they were the same as everybody else with that drug, or with that disease. And therefore, that disease should be treated kind of similarly with all people that have the name of that disease. And now we're entering into the N of one era, in which each one of us are recognized as an experiment without a placebo control, unless we have an identical twin that's doing something different, and that we need to be respected as unique in the way that we're managed. That's a medical change in thinking that is absolutely dramatic, because the whole pharmaceutical world was built around the principle of the megabuster, of like the statin drugs to treat elevated cholesterol, assuming that everybody that had elevated cholesterol could take one drug, a statin, to treat that condition successfully. And so the pharmaceutical companies obviously love that model because it gives large sales to a single product. If you start talking about not mega buster kind of drugs, but micro busters, where each individual is unique to their own condition, now it's a much more complicated approach for the pharmaceutical world, because they have to have differentiated drugs for different conditions that are unique to that person. And this is changing the whole nature of pharmaceutical science. It's changing the way that we do studies. It's changing the way that we analyze data, and ultimately going to change the way that medicine is done. Not as it's been in the past, medicine for the average, but the future will be medicine for the individual. Now, how does that track in with what's going on in the genomics and genetic analysis field? I think the most significant singular event that's occurred within the last few months has to be the 23andMe situation. We're all familiar with the fact that 23andMe was an early leader. By the way, as you know, the company was started by the former wife of one of the founders of Google. And she did a very, very good job, Emma Chicky, going out and assembling a high-powered team of genetic counselors from Stanford and other medical centers, and moving to a consumer-based genomic testing based on certain SNPs that they felt were important, certain single nucleotide polymorphisms. And the FDA stepped in and they said, well, just a minute here, this is a medical test and you're doing some degree of diagnosis and you're doing it direct to consumer with no doctor intervention and you're not genetic counselors and this is illegal. So this is an unapproved test. And to the credit of the senior leadership of 23andMe, I think they did a very, very smart thing and very intelligent thing in that they regrouped, they went back, they qualified their tests, their reproducibility, sensitivity, and precision of their analysis. They did the heavy lifting of the kind of science that the FDA wanted to see. And through kind of, well, quote, good behavior, coupled with the rising tide of interest in genomic information, so the pressure that was being put on the FDA to actually make consumers more able to get this information, which is a major change in thinking, I might add, at our Federal Food and Drug Administration, because in the past it's always been doctors are the keepers of the keys for all information, and you have to go to your doctor to get your health information, including your results of lab tests and things. And now we're starting to see accessibility of information through the direct to the patient. And they have just recently, as you know, in April of this year, the FDA is allowing the 23andMe to sell genetic tests for disease risk to consumers. So for the first time, we have a consumer-approved test, direct to consumer on genetic information that can actually give specific disease risk information without intervention by a physician. Now you can, argue whether you like this or you don't like it. I'm not going to be speaking to the philosophy here. I'm just going to be speaking to the fact that this is another major trend that demonstrates the change in how we are viewing genetic information that relates to health, not just ancestry, but actually healthcare information. So I think that what we're witnessing is a very profound alteration in the way that genomic information can be seen useful. Now, where is this ultimately going in the public health or the individual health field? I think it's going to a place that is not what most people initially expected. And I think it's very exciting that it's going where it's going. Initially, I think people have felt that if you had your genes analyzed, that what you would learn is your relative disease risk profile. You would learn what your risk to various diseases were: heart disease, cancer, diabetes, arthritis, dementia, the major concerns that people have about how their life may proceed. And so if you ask the question, how compelling is that for people on the street to know their disease risk genes, I would say that it's probably low interest. And the reason for it is that most people, including myself, really don't want to know exactly how we're going to die.
Yeah.
What we would really like to know is how we're going to live, right?
Yeah,
how we can be able to live a full life. And so it's a negative message. And, most of us don't like negative messages repetitively in our lives, even though sometimes we're living in an environment where it seems like all the messages are negative. But I think that we would be more inclined as individuals, as humans, to want to align with positive messages rather than negative messages. And the way that we frame genetic testing in the past is really kind of a negative message. It's about relative risk to disease. And I think that for the results of what we have seen over the last, say, decade, as people have had their genes analyzed, is that we've started to see more and more pushback saying, well, that wasn't really that useful for me, that I had a 10% risk of a hearing loss, or I had a 13% risk to macular degeneration and eyesight problems, or I had whatever it might be. I want to know actionable things that I can do to promote my wellness, my health, my vitality. I don't really want to know about these disease risks. And so with that in mind, if you turn the concept around, which is what's happening now, rather than talk about a disease risk, we should be talking about the genes that really promote disease resiliency, or the resiliency of our body. And that's a project that you probably are aware of, is ongoing right now, called the Resilience Project at Mount Sinai School of Medicine, at the Icahn School of Medicine in New York. headed by Eric Schott and Stephen Friend. It's a really powerful altered thought about how this genomic information will be used. And in fact, if you go to the Resilience Project website, you can see what they're doing is asking people if they would like to have their genes analyzed, actually even for free, because what they really want to do is to find people who have family histories of really serious diseases, but who have grown up disease-free. So they have fathers or brothers or sisters or mothers or uncles or aunts who have very serious genetic-related diseases. And so you say, oh, I was born with these genes, I'm going to get them. But these individuals, even though they have very high penetrance of these diseases in their families and their ancestors, or their close ancestors, that they get into their 80s and 90s completely disease-free, which says something about, well, hold on, the genes must not be controlling everything, because if they did, these people would definitely be having these diseases. So the question that the Resilience Project is asking is, what are the features that put brakes on the expression of these genes that would otherwise have been expressed as disease, and in these individuals are kept silent? And how do you then understand that so that you're patterning whatever is required to put the brakes on the expression of the genes that would be associated with the disease, and put the accelerator on the genes that are associated with health? And I think that is a very powerful new framing of the genetic paradigm. Now, one could ask, well, isn't it that epigenetics actually regulates that? So aren't there factors that are above the genome, above the genetic code, that kind of put the marks on the genes that regulate how the genes are expressed? And the answer is yes, that is true. And then people would say, well, how do you measure the epigenome? Well, that's now another part of the story, I believe, because we're starting to see the development of these wearable biometrics. And they started off, again, a little bit like the hobbyists with the microcomputers, of being pretty simple. We think of the Fitbit, for instance, or the Apple Watch. They were simple devices that measured simple things like, the hours of sleep, or they measured, in the more sophisticated models, your pulse or your steps. They had an accelerometer in them so they could measure things related to force and distance with the GPS. So we got some early information biometrically that could be then communicated through our smart device and could be put into a nice graphic program to see, gee whiz, how much exercise are we getting each day? How many calories are we expending? What's our average pulse rate? We could use it for training. We could gamify health, basically, by saying, oh, I've got a certain course that I do in my running or my biking, and I'd like to do it faster. So we could compete against ourselves, or we could compete against our friends or other people in the club. And that construct of having quantifiable information about our function and being able to use it to compete, because we are competitive animals, either with ourselves or others, gives rise to the gamification of health. And that title, tied together with the genomic information, starts to frame a new view of the human being. It frames our individual characteristics and how our genes are responding epigenetically and functionally to the way that we are living and eating and thinking and acting and being. And so I think that the wearable device innovation is only on the front edge. We're going to be able to measure over the next 10 years, non-invasively, so many new things that will help us to better understand ourselves, like blood oxygen levels, like blood sugar levels, non-invasively, like EKG patterns, heart rhythm patterns, and heart rate monitoring, and heart rate variability, non-invasively. And these things, along with things like skin temperature, and there'll be so many variables that can be now accessed that will go into algorithms in the cloud using this big data that we all have access to, and come beaming back to us with interpretation that will couple together with our genomic information to now tell us how we're functioning, where we're going, and what our opportunities are, and what we should tune up in our diet, lifestyle, and programs so that we can optimize our function. And it will be fun because we'll be making it almost like a game of life. So I think that this recontextualizes healthcare from a disease-centric model, which is kind of fearful because most people don't like talking about cancer and heart disease, to a healthcare model in which wellness becomes a major focus of our future. And I think this is happening right under us. It's birthing a new industry that it will be a several $billion a year new industry that will come out of nowhere, like the microcomputer industry did 25 years ago, that is going to be called the wellness industry versus the disease industry. So I think in the broadest sense, this would be my kind of status of where we are right now with genomics, and I can go into more detail, but maybe that's enough of a long-winded diatribe just to give my perspective on the landscape.
No, I think that's an incredible insight, and I can see why the passion is there for you to bring together the worlds of genomics and functional medicine and the wearable devices in the events and the other things that you're doing, because it's so clearly synergistic. And I'm glad you brought up the 23andMe thing, because that was really actually the impetus for me to put on this summit, because what I recognized is I think maybe 5 years ago, we could have all hoped that there would be this army of genetic counselors armed with the right information, let's say functional medicine, to be able to guide our whole, population through to making best use of this information. And I think we could all look at that and say, that's probably not quite where things are going to be, because the consumer side of this is moving so much faster as Moore's law comes in and everything gets cheaper, more access to it. Everyone's doing their testing, and there's not, the average doctor can't really help you to be able to work out what to do. And so, that one of the reasons I wanted to put on this summit was for everyone to be able to hear a message that was empowering, but was also responsible use of this information. With great power comes great responsibility. And so I guess that's where I really wanted to go next, because I know you have actually been through more genetic and genomic testing than most other people on the planet. And so, obviously that's been a real personal thing for you. And I most people who are listening to this are probably people who have maybe got their 23andMe done, and they're not really sure what to do with the information. And so I'd love to just dive into you, from a patient's perspective rather than a clinician's perspective. What has learning this information about yourself meant to you? And what is a responsible use of this information to create health?
Yeah, thank you, James. Again, I'd like to take a little bit of a maybe different path to answering your question. I hope people will see where I'm going and find this interesting or useful. Let's start with this definition that you, or this title that you gave in that previous question of genetic counseling. And, let's talk about what is a genetic counselor. And I think it's very, very important to understand how this field of genomic testing has grown up and how it has been utilized by professionals in the field. So the early first applications of genetic testing was to evaluate the genes for the presence of what are called monogenetic disorders. These are conditions that have names in the Handbook of Diseases, the Code of Diseases, that are called inborn errors of metabolism. So they have names like sickle cell anemia and hemoglobinemia and Fabry's disease, Gaucher's, Wilson's disease. I mean, I could go down the list. There's, I think, over 3,000 of these single gene mutation related to diseases. And genetic counselors are trained and are very skilled in the art of understanding these disorders, their origin, what genes are mutated, and what the situation relates to their development in children up through adulthood. And this is a very important branch of medicine. I want to emphasize, however, that this is really disease focused. These are very serious diseases, and they often are found in infancy, and they progress at times to early death, unfortunately. And so they are nothing to be taken lightly. They're very serious pathologies that we try our best in medicine to manage the symptoms of, but we have historically not had very good treatments for them. There are a few, fortunately, notable examples of treatments in the pharmaceutical industry, particularly through the development in certain companies that have, like Genzyme, that took on the responsibility early, some nearly 30 years ago, to try to develop therapies for these, what are called orphan conditions, or conditions that are related to these monogenic defects or mutations in the genes. But the majority of them are not easily treatable, I guess, is the unfortunate outcome. But the good part of the story, if there is a good part, is that these are reasonably uncommon. In the number of diseases that people experience in our culture, they are very uncommon. They represent less than 2% of the source of disease in our culture. So they are very serious in people that have them, but they're not that common in the overall population. So genetic counselors are really good in managing and communicating and analyzing these kinds of conditions. However, with said, their expertise in training and skill is not in understanding how families of genes interact in a complex environment to give rise to chronic illness. Not the monogenetic, but we call polygenic, multiple genes working as together to give rise to dysfunction, which are a much more complex pattern, but those patterns are much more related to the more common diseases that we have, like the heart disease and the diabetes and the cancer and the arthritis and so forth, which don't come from single gene problems. They come from multiple genes interacting with the environment. So the question then is raised is, well, who is going to be the people that will be the counselors for these diseases based upon genetic information? And that's a question with a question mark, because presently there is no single field that has emerged yet to be the field that owns the polygenomic lifestyle environment related genes that give rise to the dominant chronic diseases. So one of the fields that I think has a great opportunity to own a lot of that space in the medical world are the functional medicine practitioners, because they are trained to think in a systems way, systems biology. They're trained to look at multiple interactions of differing factors that aggregate together to give rise to the expression of what we call a disease. And their minds are trained to connect genes with environment and lifestyle in ways that would lead them to ask different kinds of questions of their patients than those who are seeking out the origin of monogenetic diseases in a traditional genetic counseling environment. So I believe what we're witnessing right now is a transformation, not only in the information available, looking at polygenomic or polygenetic related diseases, which are the conditions that are most prevalent in our society, but also the field of healthcare providers, professionals that will have the knowledge and the background and expertise and communication skill to discuss those with their patients versus that which a genetic counselor has traditionally done, which is to talk about monogenetic inborn errors of metabolism. And getting to my specific experience, as you mentioned, I like a lot of the techno geeks have run down the tests in the omics world quite aggressively. So I've had my genome screened both in terms of SNP analysis, like with 23andMe and pathway genomics, but I've also had full genome screens, and including the dark matter of the gene, meaning the whole thing, both the coding regions and the non-coding regions, by Veritas Genetics and by Illumina. And I've also been an active participant in the development of Wearable, which is one of the companies that is emerging to provide personal healthcare information based upon the combination of genomic and phenomic information. So I've got all this mass amount of information about my genes and their interaction with my environment. And that's been superposed for me on the fact that as a clinical biochemist, I've been actually measuring my blood chemistries quarterly with nearly 60 different analytes for the last 35 years. So I have 35 years worth of quarterly information on my blood chemistries. And now I've added to it all of this other additional information that's coming available. So what has that given me other than quite a bit of information to deal with? And by the way, this also includes now microbiome information, where I've been having my microbiome analyzed with Aeroval quarterly. So all of that then has surprisingly, given me much more precision in how I see my particular lifestyle and environment and diet interacting with my genes. And there were things that I didn't know about that have been very enlightening, I think are going to be very important as I'm moving into I'm in my 7th decade of living. So I think going forward, this information will be progressively probably more important for me. For instance, I learned that I have a series of interesting SNPs that are related to vitamin D. So I have a vitamin D receptor, two of the vitamin D receptor SNPs that show poor affinity for vitamin D. I have a transport vitamin D SNP that says that I transport across my intestinal barrier vitamin D less efficiently than others. I have SNPs that are related to the regulation of vitamin D expression in terms of its influence on immune system function. So what does that really say to me? It says, let me look at my vitamin D level. And when I do that, I find even though I have been a person who has routinely been supplementing my diet for decades and who also, I'd like to think, eats a pretty good diet. I'm very conscious about my eating and have been for a long time, that my vitamin D level, my 25-hydroxy vitamin D, the kind of surrogate marker for vitamin D status, was around 25 to 30, probably more closer to 30 when I started off 3 years ago, even though I was doing all these other things that I thought were right. So by recognizing the degree of the uniqueness of the way my body manages vitamin D and metabolizes it, I've been able then to titrate my intake of vitamin D so that now my 25-hydroxy vitamin D levels are in the 50 to 60 range, which is where I want them to be. So how does that translate into function? Well, then when I look at some of my immune function parameters, I found that because we're measuring things like cytokines and measuring various immune active intermediates in the blood, I found that they have shown improvement. So there is even in someone who is as geekish as I, by providing the right kind of information, additional information, it gives me a much more precise window to know how to really squeeze the best out of my genes, which is the ultimate objective that I think all of us have. And that is, we want to live life with maximum gusto for as long as it can be, and then, move on to the next level with as little discomfort as possible. That's as late as possible. So I think this all comes down to how we use this information and put it through the lens, and I would call it's the systems biology functional medicine lens, that allows us to best kind of assess our unique N-of-1 experience in life and how to maximize it.
There's so many parallels between, what you've seen in the shift from the conventional medicine to functional medicine. I remember when you came on the functional forum, you talked about, this shift from the diagnosis to the prognosis. It seems like this genomic revolution is right in alignment with that shift, as you've mentioned before, which is, must be exciting to see sort of another, big player coming onto our side, if you will.
Well, I think that's really well said, James. And just take a snapshot of this last year, 2016, going into 17. So we saw the emergence of Wearable, which I've already mentioned, as a company that's kind of the start of the scientific wellness economy. Then we saw Human Longevity Inc., Craig Venter's new company, and Craig being from Solera, the guy who was in charge of the company that was racing the NIH scientists for the deciphering of the human genome, was in the Rose Garden with President Clinton when they announced the collaborative deciphering of the human genome. So now he has this Human Longevity Inc. and the Health Nucleus that is doing personal health assessment out of San Diego. And then we see companies that are kind of following on with that, like Wellness FX. It's a consumer-facing company that provides analytics to consumers directly about their health, coming from genetic and genomic information. Then we saw Nobel Prize winner George Church from Harvard and MIT and the Broad with his development of Veritas Genetics. It's providing full genome screening and interpretation to direct-to-consumer. Well, actually, it's direct-to-consumer with a physician approval. Then we saw Pathway Genomics down in San Diego, in which they're providing, again, genomic information and interpretation. And then we saw uBiome, which is now formed with Jessica Richmond as its one of its co-founders, who is doing consumer microbiome testing and interpretation for microbiome in the stool. And we saw now the development of a new company called Viome that's going to be providing complex information direct to consumer on how to integrate together the genomic information with the microbiomic information, with transcriptomic information, with blood chemistries, with health information. And then Calico Biosystems in Novato, California, that's developing how to assess improvement of reduction of biological aging by being able to assess your biology and then manage it with appropriate lifestyle and diet. And by the way, Calico was founded by Dr. Arthur Levinson. I don't know if you know that name, but Levinson was the previous CEO of Genentech. He then has moved over where he is the chairman of Apple Computer, and he's funded by Google to be the CEO of Calico. So what did I just say? I just said that a biotechnologist is the CEO of a health promotion genomics and anti-aging research venture that is funded by Google, and he's the chairman of Apple. So we're really seeing incredible transformations in the way that this whole construct is weaving itself into our economy. And in fact, you probably saw just recently, I think this was in March of this year, that there was an announcement that J&J, Johnson & Johnson, has been so concerned about the burnout of its senior management, which are, their most valuable employees probably are these highly compensated senior management, and they're retiring early. Many of them are getting sick with chronic illness. So they now have a pilot program in which they're providing a dietitian, physiologist, and executive coach to do health programming for all their senior executives to see if they can reduce corporate burnout. Now, think of the implications of what I've been saying here. This is a transformative period of time in which all the old rules that we used to have are being thrown out and new rules are being developed. It's very similar, as I said, to the emergence of what happened with microcomputing, personal computing back in the 1980s.
Yeah, absolutely. Yeah, it's very clear that that's the way that things are going. And, it's so funny that most doctors that have found themselves in functional medicine have had some sort of burnout disease, child who couldn't get well moment that has thrust them into thinking differently. And that's why they've been ahead of the curve. And, not even the senior management of Johnson & Johnson can escape that now.
That's right. Exactly.
So, I'd love to just, one thing I'd like to just talk about. I know in the Silicon Valley world and probably in the genomics world, there's this concept of P4 medicine, and Dr. Leroy Hood has been speaking about this for a while. And you and I were having a conversation a little while ago about the difference between an aspirational system of medicine and a reproducible operating system for medicine. And I'd love to you just share that a little bit because, part of this summit and the goals of this summit, and I'm so glad you brought up all the companies that you did, because many of the companies that you mentioned are going to be involved in the rest of the summit. We've got the thought leaders from the labs, from the journalist end, synthesizers of information, people on the ground who are actually doing this with patients every day. So we brought a wide spectrum here. But, ultimately what I hope that this summit will do will inspire more people to want to see functional medicine doctors and more doctors to want to be functional medicine doctors. And I think to give that the context, I'd love for you to explain, first of all, the aspiration behind P4 medicine and how that translates into a reproducible operating system for creating health in an N=1 environment.
Yeah, thank you. I am so privileged personally to have met one of the great thought leaders of our age in the translational science area that pertains to genomics, and that's Dr. Leroy Hood, who is the founder of the Institute for Systems Biology, which is in Seattle. He's credited as being one of the principal discoverers of three of the instruments that were used to decipher the human genome. His background and accomplishments are truly legendary. He was a Caltech professor for many decades and was considered, and probably still is, one of the principal immunology discoverers of our age. He had a huge research group at Caltech, which was pioneering all sorts of developments in the understanding of the operational activity of our immune system and its relationship to genes and proteins. He was then wooed away from Caltech. It's a very interesting story, which I won't bore you with, but he was wooed away by Bill Gates to come up to the University of Washington, and Gates then funded a translational genomics center that Dr. Hood brought to form the Institute for System Biology and started looking at this concept that Dr. Hood really pioneered, to look at biology as a system, not as just its piece parts. and look at genes as interweaving one gene with another in their expression patterns to produce patterns of function. And through that, ultimately, Lee then, I think, founded a number of biotechnology companies, one of which he was in principle involved with was Amgen, that's grown up to be a major pharmaceutical company now with, I think, revenues in the range of $35 billion. And he was a founder of Immunex, which was the company that developed the arthritis drug Inbrel. And so he's done a tremendous amount across wide ranges of both translational biology, translational medicine, and pharmaceutical science. And through that, he eventually, I think, started to recognize that there was a gap in medicine that was forgetting the patient somehow and focused only on the disease. This is a similar kind of evolution to that which I've gone through in my career as well. I think I made that transition maybe a little earlier in terms of my patient-centered interest about the constructs of health and disease. But Lee then came up with a concept that he called P4 medicine that you alluded to, James, that stands for, the 4 Ps are predictive, preventive, personalized, and participatory. And obviously it's an engagement form of healthcare that brings the patient into the theater of control, the locus of control of their own condition. So this medicine, rather than being reactive, it's proactive, so it's predictive. It's focused on prevention rather than just treatment. It's personalized the individual need, and it requires the participation of the person. They're not just a passive observer, they're part of their own particular therapy. And you'll notice that this links very closely to the constructs of functional medicine. So this aspirational model, predictive, preventive, personalized, and participatory, what he calls P4 medicine, I think gets applied clinically through an operational system that we call functional medicine. That's really how you take these objectives and you put them into a clinical teachable program that practitioners can actually implement in their practices successfully. So I've been very pleased over the last 3 or 4 years to have an increasing alliance with both Dr. Hood and his vice chair of the Institute for Systems Biology, Dr. Nathan Price, and that we're collaborating in a variety of different projects. Since the last year, something has happened which I think is also indicative of the changes occurring in healthcare right now, in that Dr. Hood has now signed on as the Chief Scientific Officer for the 3rd or 4th largest health system in the United States, called the Providence Health System, which I think they have 57 hospitals. So this is Providence, Swedish, and St. Joe's. It's the Western United States major system. And he is now the Chief Science Officer of that organization. And the Institute for Systems Biology has now been brought in as a research arm of the Providence healthcare system. Now, why is that interesting? It's interesting because the CEO, Rod Hochman, of this system has then made a judgment, a determination that all of the employees of the St. Joe's Providence Swedish system will, I think it's, I don't know, it's something like 15,000 employees, I don't remember the exact number, will all be offered the Arabal assessment for designing personalized wellness. So here is a major hospital-based system that recognizes there is an opportunity for creating a wellness space that has now aligned itself with arguably one of the leaders in systems biology and systems healthcare in the world, Dr. Hood, and is engaged now in personalized lifestyle medicine delivery through the P4 medicine concept. So you'll notice that when we have our meeting coming up, our fall Thought Leaders Congress that we do every year, that the Personalized Lifestyle Medicine Institute does, that this October 13th and 14th meeting, which will be held in Seattle, has all of these people I just mentioned as key presenters, because what I really want to start examining is these new models of healthcare. How are they really going to work? How are they going to be funded? Who's going to train practitioners? What does this system look like? How is it going to set aside a disease care model when we start having a wellness model? I mean, they don't have to be mutually exclusive, but somehow they have to find residence in both our economy, training, and practice. So our October 13th and 14th meeting will have a discussion with Rod Hochman and Lee Hood to talk about how can you really vet these systems in a hospital-based environment. So I think it's really a time of disruptive innovation. It's a time of unbelievable opportunity. And it's a time where convergence and emergence are the two central features of our age. Convergence of different disciplines with an emergent structure that comes from the bottom up, not from the top down. This doesn't come from a bunch of people sitting in rarefied areas and designing the system. It's coming from the emergence from the bottom up, from the healthcare consumer driving healthcare change, just like Eric Topol talked about in his book, The Patient Will See You Now. We're really seeing an emergent new system that is related to the convergence of different disciplines, and a very exciting time.
Absolutely. Well, look, thank you for summing that up so nicely. And I will be there on October 13th and 14th at the PLMI Thought Leaders Convention. I hope that if you're listening to this and you consider yourself a thought leader in the space, or you'd like to, be involved in this area, that you will come and join us. You can find out more about that at the plminstitute.com.org. .org. Yeah, exactly. plminstitute.org. You can find out more about that meeting. I think it's going to be another sort of key moment, in the context of, of how those things fit together that you were just mentioning. It seems to me that this scientific wellness, this new era of scientific wellness, the only real place for it to sit in relation to medical care is in front of it. It seems as though, this is a lot easier to innovate with. And if we want to really take the pressure off the downstream systems of medicine that we call hospitals and clinics and so forth, that, going upstream and delivering these scientific wellness tools to the masses so that they can empower themselves to keep themselves well and keep them out of the system, seems to me the only iteration that makes any sense. Would you echo that?
Absolutely, James. I think that is the watchword of really where we're going. And it's interesting to me that as I look at the evolution of this field, which is rapidly occurring, by the way, if you sit on your hands for a couple of days, things are already changing, that what we are really seeing emerge is a new financial and economic model that will allow healthcare to become a venture that people want to participate in. In the past, you've had a lot of people that were very interested in healthcare, but there was no way you could really make a living for it. All the economic incentive was disease care. And so the great minds, men and women who went into healthcare, really ended up gravitating into disease care. And I think now we're opening up an economic model that will incentivize through providing a reasonable opportunity to earn a living in actually being focused on delivering personalized healthcare. So it's a very remarkable time, and it's actually the perfect time for functional medicine, which is built on a systems biology approach to medicine. So I think the chapters are being written. It's emerging. It's not controlled by, I think there's still people that feel that they can control this. It's not controllable. It has its own motive force, its own origin, its own energy, its own kind of destiny. And sometimes the truth takes a while to shine through, but I think it ultimately does. And we're going to see over the next 10 years something that will happen as dramatic as what we saw with personal computing in the previous decades.
I'm absolutely convinced that that is the case, and very excited to be on this journey with you, Dr. Bland. My sincere thanks for providing this keynote for the summit. I think it's a perfect starting point to everything that's to come. Just as a look into people who are listening to this, during the summit, we're going to hear from doctors from the front lines who have been counseling and working with practitioners on how to improve their resilience and their health. We're going to hear from some of the innovations in the omics. You heard Dr. Bland talk about genomics, but also metabolomics and transcriptomics and some of these other areas that have evolved out of the space. We're also going to have a session later in the summit for health professionals. How do I actually set up a practice doing this type of work? Because ultimately, we've seen over the last few years that there are many, many doctors that feel a moral obligation to practice this new era of medicine, but haven't been able to get their head around what it actually means to do this day to day and how to sort of extricate themselves from the system and work with patients directly. So we're very excited to be bringing this summit to the world. And my sincere thanks, Dr. Bland, for your vision and your follow through with that vision, and also, just your ability to articulate and communicate exactly where we are and where we're going. And yeah, it's a great time to be alive.
It certainly is, and I think we're going to be able to reduce the unnecessary burden of disease for many, many people in the years to come by the application of what you're talking about. So I thank you for your advocacy. It's really the ultimate objective for all of us is to help people lead happier, healthier, longer lives. And that I think is part of the what's materializing out of this movement.
Absolutely. Well, this has been the Interpreting Your Genetics Summit. This has been the keynote with Dr. Jeffrey Bland. To find out more about his work, you can go to plminstitute.org, find out more about the events coming up. There's a whole history of content on that site as well. Thanks so much for being with us. Enjoy the summit, and we'll see you next time.